Hello guys, welcome back to another video. In this video we will consider the limit of the following sum. So how will we proceed? We will rewrite 1 over k and 2 to the k minus 1 as an integral. So we will rewrite the other things as follows. Sum going from k equals 1 to n minus 1 to the k minus 1 n over k. And then we rewrite the highlighted thing as an integral x to the k minus 1 from 1 to 2. So what do we do now? We switch the order of integration and limit. We will not write limit every time because it is not necessary. We will just put L, and now we will interchange the limit and the sum. I mean the integral and the sum. So we get a sum going from k equals 1 to n minus 1 over k minus 1 n over k times x to the k minus 1 dx. Alright, so what will we do now? We will, again, we have the limit, an integral from 1 to 2, k goes from 1 to n minus 1 or k minus 1 n over k, and then we will rewrite this x to the k over x. And if you take a look at this part on the top, you can see that it is actually a binomial sum, but the 1 is missing. So we will rewrite this as the follows. So limit as n goes to infinity, an integral from 1 over 2, we add 1 and subtract 1. So what do we have? We have 1 minus x to the nth power over x dx. So we have a limit as n goes to infinity, an integral from 1 to 2, 1 over x dx minus an integral from 1 to 2, 1 minus x to the n over x dx. As you can see, we have just a limit as n goes to infinity of this part. It will be just ln2 minus, we will now focus on this part. Let's consider this integral. From 1 to 2, 1 minus x to the raised to the power n over x dx. This is less than an integral from 1 to 2, 1 minus x raised to the power n dx. And why is this less? It is less because we are dividing by something that is from 1 to 2, so this is strictly less than this one. We introduce a substitution, 1 minus x equals t, and when solved, we will get t to the n plus 1 over n plus n over n plus 1 from minus 1 to 0. So at the end we will have minus 1 to the n plus 1 over n plus 1. And from this side we can clearly see that this is not negative. It will be a positive quantity. And if we let a limit on both sides, we see that this part will go to 0, and it is strictly bigger than 0, so this must be 0 by the squeeze theorem. So this part is actually 0. So at the end we have just ln2, and this is the solution to our problem. Alright guys, thanks for watching. I hope you like this problem. See you in the next video. Bye guys.